Hello, everyone. Tonight, as you settle into warmth and safety, we're going to journey somewhere impossible, somewhere that defies everything we think we know about life, to the world of the most indestructible creature on Earth. A creature so small you need a microscope to see it, yet so resilient it can survive almost anything. The Tardigrade, also known as the water bear or Moss Piglet. These microscopic animals, barely visible to the naked eye, carry within them survival abilities that seem like science fiction. They can survive in the vacuum of space, in boiling water, in solid ice. They can withstand radiation 1,000 times stronger than what would kill us. They can live for decades without food or water in a state of suspended animation. And when conditions improve, they simply wake up and continue living as if nothing happened. How is this possible? How does something so small, so seemingly fragile, become the most indestructible animal we've ever discovered? Tonight, we'll drift through their secrets, one by one, gently exploring each superpower of survival, each adaptation that makes them nearly immortal. There's no rush. Let yourself sink deeper, and together we'll discover how tardigrades became the ultimate survivors. But before we begin, please like and subscribe. It really makes me happy. Let's begin our journey into their microscopic, indestructible world. The first thing to understand is what a tardigrade actually is. These creatures are tiny, truly tiny. Most species measure between 0.3 and 0.5 millimeters long. That's about the size of a grain of sand, or smaller. Under a microscope, they look almost adorable. A plump body, 8 stubby legs, each ending in tiny claws. A rounded head with a mouth that looks like a small tube. They waddle when they walk, moving slowly, deliberately, like tiny bears. That's where the name water bear comes from, this bear-like gait. And they live almost everywhere. In moss, in lichen, in soil, in leaf litter, in puddles, in ponds, in the ocean depths, from mountain peaks to deep sea trenches, from polar ice to tropical rainforests. Anywhere there's even a little bit of moisture, tardigrades can be found. There are over 1,300 known species, and probably thousands more we haven't discovered yet. Each species slightly different, adapted to its specific environment, but all of them sharing those remarkable survival abilities. All of them nearly indestructible in ways that seem impossible. They eat by piercing plant cells or bacteria with their tube-like mouth, sucking out the contents. They reproduce, they grow, they live their tiny lives. Most live only a few months under normal conditions. But normal conditions for a tardigrade are rare because their habitats, moss and puddles and soil, they dry out constantly. And that's where the magic begins. Tardigrades evolved over 500 million years ago, back in the Cambrian period. Ancient ancestors, probably living in marine environments at first. But as life moved onto land, as plants colonized the continents, tardigrades followed. They adapted to life in moss, in soil, in places that experience extreme fluctuations. Wet one day, bone dry the next. Warm in summer, frozen in winter. These environments are harsh, unpredictable, constantly changing. Most animals couldn't survive such instability. But tardigrades, they evolved something extraordinary. The ability to enter a state called cryptobiosis. A state of suspended animation where life processes stop almost completely. This happened gradually over millions of years. Tardigrades that could survive brief dry periods had an advantage. They lived longer, reproduced more, passed on their genes. Generation after generation, the ability became more refined, more extreme, until we arrived at what we see today, tardigrades that can survive almost anything. Not because they're trying to, not because they're strong in the traditional sense, but because they can simply turn off, shut down, wait. And waiting, it turns out, is the ultimate survival strategy. We humans, we're so fragile in comparison. We need constant temperature regulation, constant hydration, constant oxygen. Take away our water for a few days, we die. Expose us to extreme cold, we freeze. Expose us to extreme heat, we cook. Radiation, vacuum, pressure, these things kill us quickly. We're adapted for a narrow range of conditions, and outside that range, we fail. Tardigrades laugh at our limitations, if they could laugh. They experience extremes we can barely imagine, and they survive, not by fighting the conditions, not by resisting them, but by shutting down so completely that the conditions don't matter anymore. It's not strength, it's surrender. Total, complete surrender to the environment. And paradoxically, that surrender makes them indestructible. Picture a patch of moss on a rock. It's been raining, and the moss is swollen with water, green and vibrant. Inside the moss, thousands of tardigrades are active. A tardigrade named Titan is crawling through the moss strands, searching for food. She finds a plant cell, pierces it with her mouth, feeds contentedly. Life is good. Water is abundant. Food is available. But then the rain stops. Days pass. The sun beats down. The moss begins to dry out, slowly at first, then faster. Water becomes scarce. The moss turns brown, brittle, and Titan senses this, senses the water disappearing. Her body begins to change, begins to prepare. She pulls in her legs, curls into a tight ball. Her metabolism slows, then slows more, then nearly stops. She's entering a state called a ton, the cryptobiotic form. Within hours, she's completely transformed. Her body has expelled almost all its water, down to just 3% of normal. She's replaced the water with a sugar called trehalose, which forms a glass-like protective matrix. Her cells are preserved, protected, suspended in time. She's no longer really alive, but she's not dead either. She's waiting. Days pass, weeks pass, months pass. The moss is completely dry now, a dead-looking brown mat. Titan remains, a tiny barrel-shaped ton, inert, dormant, patient. Then one day, rain returns. Water seeps into the moss, soaking it, reviving it. The water reaches Titan, and slowly, impossibly, she begins to wake. Water is absorbed back into her cells, replacing the trehalose. Her legs unfurl, her body expands, her metabolism restarts. Within hours, she's moving again, searching for food again, living again, as if no time had passed at all. That's the first superpower, cryptobiosis, the ability to pause life itself. There's something profound about this, about the ability to simply stop. We live in a world that demands constant activity, constant engagement, constant presence. We're afraid of pausing, afraid of stopping, afraid that if we shut down, we'll never restart. But tardigrades teach us that sometimes the wisest response to impossible conditions is to simply wait them out. Not to fight, not to struggle, not to exhaust yourself, just to pause, to preserve, to trust that conditions will change. And when they do, you'll be ready, you'll wake up, you'll continue. There's no shame in shutting down when the environment becomes hostile. Sometimes that's not weakness, that's the ultimate survival strategy. Wait out the storm, preserve yourself, trust in the pause. Now let's talk about the extremes they can survive. Because cryptobiosis doesn't just help them survive drought, it makes them nearly indestructible to almost everything. Temperature extremes, for instance. Tardigrades in their ton state have survived temperatures as low as -272 degrees Celsius. That's just 1 degree above absolute zero, the coldest temperature possible in the universe. And they've survived temperatures up to 150 degrees Celsius, far above the boiling point of water, from near absolute zero to far beyond boiling. And they survive unchanged, ready to revive when conditions normalize. They've been subjected to intense radiation, doses that would kill humans instantly, exposed to X-rays and gamma rays thousands of times more intense than lethal human doses. And they survive, their DNA remarkably resistant to damage. They've been sent into space, exposed to the vacuum, to cosmic radiation, to solar radiation. No air, no pressure, no protection. And they survived, revived when brought back to Earth, continued living. They've been subjected to pressures 6 times greater than the deepest ocean trenches, crushing forces that would destroy almost any other organism. And they survived, compressed but intact, ready to revive. It seems impossible, but it's been tested, verified, documented countless times. Tardigrades are the most extreme survivors we know of. This extreme resistance evolved because cryptobiosis is such a complete shutdown. When a tardigrade enters the ton state, when it replaces its water with trehalose, it creates a protective glass. This glass stabilizes proteins, stabilizes cell membranes, prevents ice crystal formation, prevents heat damage. It's like putting every cell in suspended animation, perfectly preserved. And they've evolved special proteins, damage suppressor proteins, that protect their DNA. Even when radiation does cause damage, these proteins help repair it when the tardigrade revives. Millions of years of evolution in harsh, fluctuating environments created these adaptations. Only the most resistant individuals survived repeated freezing, repeated drying, repeated stress. And they passed on their extreme resistance, refining it, perfecting it, until tardigrades became the champions of survival, the ultimate extremophiles. We humans, with all our technology, can barely imagine such resilience. Our most advanced spacecraft, our most sophisticated equipment, it all has limits. Radiation shielding, temperature controls, pressure suits. We need all of this just to survive in space. And even then, we're vulnerable, limited, fragile. A tardigrade needs nothing, just its own body, its own biology. It can be frozen solid and revive, boiled and revive, irradiated and revive. We study them, hoping to learn their secrets, hoping to apply them to preservation, to medicine, to space travel. How do they protect their DNA? How does the trehalose glass work? How do their proteins function? We're still learning, still discovering, still amazed. These tiny creatures, invisible to the naked eye, teaching us about the limits of life itself. Or rather, teaching us that there are no limits, not really. Life, given the right adaptations, can survive almost anything. Imagine a laboratory. Scientists are conducting an experiment. They've collected tardigrades, thousands of them, all in their ton state. Small, barrel-shaped, dormant. One group is placed in a freezer, cooled to minus 200 degrees Celsius. Extreme cold, colder than anywhere on Earth's surface. Another group is placed in a pressure chamber, subjected to crushing forces. Another group is placed in a radiation chamber, bombarded with gamma rays. Another group is placed in a vacuum chamber, all air removed, simulating space. The scientists wait. Hours pass, then days. Then they return the tardigrades to normal conditions. Room temperature, normal pressure, normal atmosphere, a drop of water. And slowly, across all the groups, the tardigrades begin to revive. The frozen ones thaw, absorb water, unfurl their legs. The pressurized ones decompress, wake up, start moving. The irradiated ones repair their DNA, restart their metabolism, live. The vacuum-exposed ones rehydrate, revive, continue as if nothing happened. Over 90% of them survive, across all conditions. The scientists marvel, take notes, run more tests, because it shouldn't be possible. But it is. These tiny creatures surviving what would kill almost anything else. Not through luck, not through chance, but through perfect adaptation. Through millions of years of evolutionary refinement. They are proof that life is tougher, stranger, more resilient than we ever imagined. There's a lesson here about resilience, about what it really means to survive. We think of survival as active resistance, as fighting back, as strength and power. But tardigrades show us another way. Survival through surrender, through patience, through waiting. They don't fight the extreme cold, they simply shut down until it passes. They don't resist the radiation, they just protect what matters and repair the damage later. They don't struggle against the vacuum, they just wait for atmosphere to return. It's a different kind of strength, a quieter kind, a more patient kind. And maybe we could learn from this in our own lives. When conditions become impossible, when stress becomes overwhelming, when the environment turns hostile, maybe the answer isn't always to fight harder. Maybe sometimes it's to pause, to protect what's essential, to wait for conditions to change, to trust that they will change, that nothing lasts forever, not even the worst circumstances. And when they do change, we'll be ready, we'll revive, we'll continue, preserved, intact, ready to live again. Now let's talk about their longevity, their relationship with time. Under normal conditions, tardigrades live for a few months, maybe a year or two. But when they enter cryptobiosis, when they become a ton, time stops meaning anything. They can remain in this state for years, decades, possibly centuries. The longest confirmed survival is over 30 years. A tardigrade frozen in Antarctic moss for 30 years, then revived, still viable, still able to reproduce. But there are hints they could survive much longer. Tardigrades have been found in amber, in ancient ice, in conditions suggesting hundreds or even thousands of years of dormancy. And when revived, at least some of them wake up. They could potentially survive for millennia in the right conditions. Because when life is paused, when metabolism stops, aging stops too. Time passes, but they don't experience it. They're not getting older, they're just waiting. And when they wake, they continue from exactly where they left off. It's not immortality, not exactly, but it's close. It's the ability to skip through time, to wait out entire eras, to survive into futures unimaginably distant. This evolved because their habitats are so unpredictable. A puddle might dry up for a week, or a year, or a decade. Moss might stay dry through entire seasons, entire years, entire climatic shifts. Tardigrades that could wait longer, that could remain viable through longer dry spells, they survived more often. And so the ability to remain dormant extended, generation after generation, until it became what we see now, potentially unlimited. Dormancy, bounded only by the physical degradation of their ton form. As long as the protective glass holds, as long as the proteins remain stable, they can wait. And they do wait, patiently, perfectly, timelessly. We humans, we're trapped in time. We age constantly, continuously, inevitably. Every moment that passes takes something from us, moves us closer to our end. We can't pause it, can't stop it, can't wait it out. We're locked into the forward march of time, and it's relentless. Tardigrades can step outside of time, at least partially. They can pause their aging, their decay, their progression toward death. And when they step back into time, they haven't lost anything. They're exactly as they were. It's a form of time travel in a way, jumping forward without experiencing the journey. We dream of this. We write stories about it. We wish we could do it. But tardigrades, they just do it. Naturally, instinctively, perfectly. Picture a mountain valley, high in the Alps. It's the year 1920. Snow is falling, covering everything, the world going quiet and white. In a patch of moss on a rock, a tardigrade named Echo enters her tun state. The snow covers her, buries her, freezes solid. Years pass, decades pass, the world changes. Wars happen, technologies are invented, civilizations rise and shift. The climate warms, the glacier retreats slightly, but Echo remains frozen, dormant, unchanged. The year is now 2020, a full century later. Researchers are studying the retreating glacier, collecting ice samples, examining ancient moss. They find Echo still in her tun form, frozen for 100 years. They take her to a laboratory, warm her gently, add water, and slowly, impossibly, she begins to move. Her legs unfurl, her body rehydrates, her metabolism restarts. She wakes up in a world 100 years older than the one she left. But to her, no time has passed at all. She doesn't know about the century, doesn't care about the changes. She just starts looking for food, starts living as if nothing happened. Because for her, nothing did happen. She skipped it all, waited it out, emerged unchanged. A living time traveler, a survivor across centuries. And she could do it again, potentially, sleeping through another century, another millennium. As long as she remains frozen, remains dormant, she could outlast civilizations. There's something beautiful and melancholy about this, about the tardigrade's relationship with time, the ability to wait out anything, to survive through patience alone, but also the loneliness of it, in a way, skipping through time while the world moves on. Though, of course, tardigrades don't feel loneliness, don't experience melancholy. They just are, just wait, just survive. And maybe there's wisdom in that too, in accepting time as it comes, in not fighting it. When conditions are good, live fully, actively, presently. When conditions turn harsh, pause, wait, preserve. Don't force yourself to keep going when the environment won't support it. And don't feel guilty for pausing, for waiting, for taking the time you need. Because when you emerge, when conditions improve, you'll still be you, ready to continue, ready to live, ready to keep going. Time will have passed, but you'll be preserved, intact, ready. Finally, let's talk about what tardigrades mean for life in the universe, because their survival abilities have profound implications. If life can survive such extremes, if it can pause indefinitely, if it can withstand space itself, then life could spread. Tardigrades could survive on a meteorite, blasted off one planet, traveling through space for millions of years, landing on another planet. This is called panspermia, the idea that life spreads between worlds. And tardigrades make it possible, even likely. They've already survived in space, we've tested it. They could survive the journey, the vacuum, the radiation, the cold. And when they landed, if conditions were right, they could revive. This means Earth's life could potentially spread to other worlds. Or life from other worlds could have come here. Maybe tardigrades aren't even originally from Earth. Maybe they arrived on a meteorite billions of years ago and colonized our planet. We don't know, but it's possible, and that's remarkable. It changes how we think about life, about its origins, about its distribution in the universe. Life might not be confined to single planets, single star systems. It might travel, spread, colonize, seeding the cosmos with organisms like tardigrades. This evolved not for space travel, of course, but for survival on Earth. For surviving drought, freezing, heat, radiation in terrestrial environments. But those same adaptations happened to make space travel possible. It's a happy accident, an evolutionary bonus. Tardigrades didn't plan to become cosmic survivors. They just needed to survive moss and puddles. But in doing so, they became the toughest life form we know, capable of surviving anywhere. We humans, we're searching for life on other planets, in other star systems. We're looking for microbes, for simple organisms, for anything alive. And we're realizing that life might be tougher than we thought, more widespread, more resilient. If tardigrades can survive what they survive, what else might be out there? What other organisms have we not discovered? Even more resilient, even more extreme. Life might be common in the universe. We just haven't found it yet. Because it's small, because it's dormant, because it's waiting. Tardigrades teach us to look harder, to expect the unexpected, to imagine broader possibilities. Life is strange, diverse, resilient beyond measure. And somewhere out there, on some distant world, there might be something even tougher than a tardigrade. Or maybe tardigrades are already there, waiting to be discovered, survivors across the cosmos. Imagine a distant future. Humanity has spread to other star systems, built colonies on distant worlds. On one planet, a harsh world with thin atmosphere and intense radiation, colonists are struggling. The environment is hostile, deadly, almost impossible to survive. But scientists studying the local geology find something. Tiny organisms in the rocks, in the ice, dormant but viable. They bring them to the lab, add water, warmth, and the organisms revive, start moving. They're tardigrades, or something very similar. Earth tardigrades, perhaps, carried here on an ancient probe, or a meteorite, or native tardigrades, evolved independently, proving that this strategy works universally. Either way, they're survivors, they're teachers. The scientists study them, learn from them, apply their strategies, new preservation technologies, new radiation shielding, new approaches to surviving extreme conditions, all inspired by these tiny, indestructible creatures. And humanity survives on this harsh world, thrives eventually, thanks in part to lessons learned from tardigrades, the smallest teachers guiding the largest students across light years, across time. Because survival wisdom, it transcends species, transcends planets, transcends distance. It's universal wherever life exists. It learns to endure, to adapt, to persist. And tardigrades, they're the masters, the ultimate survivors, the proof that life is tougher than we ever imagined. Let's step back now and see the whole story. The evolutionary journey of the tardigrade, from ancient origins to ultimate survivor. It begins over 500 million years ago in the Cambrian seas. Early tardigrades, probably marine, simple, small. They evolved from some common ancestor, probably shared with arthropods, probably segmented and small. They were successful, spread widely, diversified. Then, as plants colonized land, as terrestrial habitats opened up, some tardigrades followed. They adapted to life in moss, in temporary water films, in unpredictable environments. And this is where the magic happened. The pressure of drying out, over and over, generation after generation. Those tardigrades that could survive brief dry spells lived longer, reproduced more. And gradually, the ability to enter cryptobiosis evolved, refined, perfected. Along with it came resistance to cold, to heat, to pressure, to radiation. Because cryptobiosis, the ton state, it protects against all of these. Natural selection favored the most resistant, the most patient, the most durable. And over millions of years, hundreds of millions of years, tardigrades became what they are, the toughest organisms on Earth, able to survive anything. They spread globally into every habitat imaginable. Mountains, oceans, deserts, poles, everywhere. Over 1,300 species, each adapted to its niche, but all sharing that core resilience. And they've survived through mass extinctions, through climate shifts, through everything Earth has thrown at life. When the dinosaurs died, tardigrades survived. When ice ages came and went, tardigrades survived. When continents split and merged, tardigrades survived. They're older than most lineages, tougher than almost anything, more persistent than we can imagine. And they'll probably outlast us, outlast humanity, outlast most of what exists today. Because they can wait out anything, survive anything, endure anything. That's the deep story, the evolutionary story of becoming indestructible. Not through strength, not through size, not through intelligence, but through patience, through adaptation, through the wisdom of knowing when to pause. So here we are, at the end of our journey into the world of the water bear. We've drifted through their secrets, their superpowers of survival. Cryptobiosis, the ability to pause life itself, to become a dormant tune, to wait indefinitely. Extreme resistance, surviving temperatures from near absolute zero to far beyond boiling. Surviving radiation and vacuum and crushing pressure. Longevity through dormancy, sleeping through decades, centuries, potentially millennia, skipping through time unchanged. And cosmic implications, the possibility of spreading life between worlds, of surviving in space, of teaching us about life's potential in the universe. We've seen how it all evolved, slowly, over hundreds of millions of years. Each adaptation, a response to the harsh reality of life in moss, in puddles, in unpredictable environments, until tardigrades became what they are, the ultimate survivors, the most resilient life we know. But here's what strikes me most as we prepare to drift into sleep. The tardigrade doesn't think of itself as tough, as special, as remarkable. It doesn't know it can survive space, doesn't understand its own resilience. To the tardigrade, it's just living, just being, just doing what comes naturally. When water disappears, it curls up and waits. Simple as that. When water returns, it wakes up and continues. Simple as that. No drama, no struggle, no awareness of how impossible it all is. Just existence, just survival, just patience. And maybe that's the real lesson, the thing worth carrying into sleep. That resilience isn't about being strong, about fighting, about resisting. It's about knowing when to pause, when to wait, when to simply endure. It's about trusting that harsh conditions are temporary, that they will pass, that you can outlast them, not by fighting them, but by shutting down, preserving what matters, and waiting for them to change. The tardigrade survives not because it's powerful, but because it's patient. Not because it fights the drought, the cold, the radiation, but because it waits them out. It surrenders completely to the conditions, protects itself, and trusts in time. And that trust, that patience, that surrender, it makes them nearly immortal. Maybe we could think about ourselves this way. When life becomes impossible, when stress is overwhelming, when the environment turns hostile, we don't always have to fight. Sometimes we can pause, protect what's essential, and wait. Wait for conditions to change, wait for the storm to pass, wait for water to return. Not giving up, not dying, just pausing, preserving, trusting. And when conditions improve, when they always eventually do, we can wake up. We can unfurl, rehydrate, restart, continue. From exactly where we left off, intact, preserved, ready. We don't have to power through everything, endure everything actively, fight every battle. Sometimes the wisest thing is to curl up, shut down, and wait. To trust in the pause, to trust in time, to trust that you'll wake up when it's time. So as you drift off tonight, Let that settle in. The image of a tiny water bear curled into a ton, waiting patiently. Not struggling, not fighting, just waiting, trusting, enduring, surviving the impossible through the simple act of patience, through the wisdom of knowing when to stop, when to pause, when to simply be dormant, and trusting that when the time is right, when conditions return, life will resume. You are more resilient than you think, more capable of waiting, more able to survive. You don't need to fight everything, resist everything, be active through everything. Sometimes you can rest, really rest, deeply rest, preserving yourself. And when you wake, you'll be intact, ready, unchanged by the harshness you waited through. That's the gift of the tardigrade, the lesson of the water bear. Survival through patience, resilience through rest, endurance through trust. Rest now, deeply, completely, like a tardigrade in its ton, letting everything shut down, everything pause, everything wait, trusting that when it's time to wake, you will, ready and whole. Let the image drift through your mind, settling, calming, soothing. The tiny survivor, patient and perfect, waiting through extremes, waking to continue. You are like this. You can do this. You are built to endure, not through constant fight, but through patient pause, through trusting rest. Sleep now, peaceful, dormant, preserved, like a tardigrade waiting through the impossible, knowing it will wake, knowing it will continue. Everything is well. Everything is exactly as it should be. Good night.